As Arpit said, I think we've been mentioning AI so many times since this morning, and it's time to kind of go to the next level of details and understand how all these technologies that were mentioned can be put to use and build all the application. And if you listen to Dr. Feng's presentation in the morning, you've seen all these videos, nice videos about the AI use cases and implementation, but I'm sure you're curious about how it really works. So as most of you are in some part of the journey toward actually using AI, not just talking about AI, but if you're like me and trying to keep track of all the latest trends and emerging technologies, you probably feel your head spinning as much as I do, and it's time to kind of maybe more orderly go through things and try to understand what they are. And I think that we are, after all, at the Open Networking and Edge Summit. So it's not enough to talk about AI in general, but it's important to understand how this general purpose technology can be put to use for a specific industry like networking or like Edge. So what can we use off the shelf as is, and what do we need to develop in our own domain of networking and Edge? So we'll try to clarify this a little bit. And Fatih will take over the next part of this presentation, and we'll try to explain to you through some examples and experimentations how these technologies can be used to build the applications. So.
Hello, hello, hello. Welcome to our session. My name is Fatih. I'm based in Dallas, Texas, as you'll see on my jersey, Texas Rangers. And my background is, obviously, I born and grew up in the telco domain with Nortel, Ericsson, and then goes Verizon as a platform engineer for Verizon Cloud. Afterwards, Google, with the Google Cloud, Edge, Antos, all them sad stories. And last 5 years at Red Hat, mainly from platform engineering to application modernization with 12 factors, and then going to cloud native. Here comes the impact of data. This is why we are having this conversation. So the question was, we were put on the spotlight for what AI means, not necessarily for everybody, but mainly for as attendees here for networking. So AI means using data to create some shape and form of intelligence to make your life easier, better, scalable, and less expensive. So that's the whole point of AI. Make things much easier, less expensive, so we can enjoy our lives in a better way, as in the Jivan's paradox. As everybody talking, once the technology becomes a commodity, it gets cheaper, the impact domain grows a lot. And so more use cases, more places to use. So the impact of AI in our domain in networking, it started with external API usages from hyperscalers. So it was like contact center AI modernization. Is it going? Still there. And so on and so forth. Then here comes the regulations. Regulatory officer said, hey, you cannot call external services in public because you're passing critical private information. So that brings those models, AI models, into in-house. As we are talking today, we are talking about DeepSeek, mainly open source, Llama, open source, Mistral, Granite, so on and so forth. But then here comes the impact. Impact is obviously the consumption of the infrastructure. Infrastructure dependency of AI models accuracy is huge. By means of the very first day you're buying it with the total cost of ownership with CapEx, and then you have to maintain it with the power, the cooling, the people. The OpEx is also high too. And then this is a very fast-paced train, applied AI in networking. As we are walking literally daily basis, there's a new development coming, not necessarily new version of the models, but also how those models being utilized for networking purposes. If you're following the industry, one of the big impacts the DeepSeek did, not necessarily being a really good, accurate model, but also the mixture of expert and selective activation of layers for per use case. That brought up the efficiency of the model to able to run for different intents, for different use cases in a different, less expensive way. So as the train going very fast, one of the key topics from MWC this year was agentic AI. So agentic AI taking AI journey for networking into one step further to making things more in a fashion of 12 factor, meaning microservices way of consuming AI in a more autonomous way. Say I have an agentic AI that can monitor my systems, collect data autonomously, make decisions using external toolboxes, leveraging a new protocol called, it could be MCP by Anthropic, or by ACP by IBM, or more are coming. I heard the Cisco is kind of doing the similar thing. By means of making agentic AI agents consuming less resources where they are running, but leveraging external capabilities and data sources and toolboxes through a communication channel, which is networking. So there will be multiple agents, theoretically. One is as diagnostic agents, one is execution agent and planning agent. These are all independent agents which can deliver a task by themselves as well as communicate among themselves as well. This is the software part of the architecture. The deployment is a different story. So we saw a lot of good presentations this morning about the edge, impact of edge in the networking domain, the data, the observability. The deployment architecture of AI services, it could be either agentic or previous way of doing things. Could be either centralized architecture or distributed architecture. As being a platform SRE, guess which one is my favorite? Centralized one. Because it's easier to manage. It's easier to manage, easier to order bill of materials. There are not many variations of the hardware. And also I can predict the capacity. I can predict the demand. Very straightforward. The downside is obviously for value generation for business side. So the distributed architecture is more popular for business purposes, for business people to justify additional use cases, create more revenue channels, saying that, hey, we have this distributed architecture, we have some edge AI capacity at edge, offering lower latency and better data locality. There was a statement this morning which I don't necessarily agree, saying that American hyperscalers are not good for European because they don't have data centers. It's not true. American hyperscalers have data centers in Germany, in UK, everywhere. It's not that. It's mainly about, is that infrastructure being designed for the need of local businesses? Okay, say in UK you have different measurement systems, different approach to different use cases and problems because they're different countries, they're different people, different organizations, different society. So that's the thing. The design may not necessarily fit into your country due to it's a different country, a different business. All right. So the way we are going, obviously, in the middle of these two, as the path to Nirvana is the middle path, is mainly about the workload distribution and also intelligence-based network design. Say I have a central data centers that is beefed up with the most expensive, the highest capacity GPUs and accelerators. But that selection of that central data center will be based on your workload type. Say I have very complex workloads. Say I have to decide whether move my train in a faster pace between the regions that may require vision as well as audio as well as other data analysis that may require central data center. So in regional data centers that may run smaller models, mid or small size language models, maybe between 7 to 30 billion parameters. And then going edge, maybe at edge we may have still AI models to run. Again, smaller size models may fit in the different hardware profile. Say it could be NVIDIA L4s and T4 sort of thing. So when you go from I shall not buy a certain GPU, but I should invest based on my workload characteristics. So what is your workload characteristics? Could be highly volatile workloads, customer support cases, outages that is based on not only metrics, but also events, logs, and traces that require a lot of processing. It could be a predictable workload, mainly based on metrics. I can look at the availability, the radio signal level, or congestion level metrics, and I can predict those based on, even with classic AI models such as logistic regression, isolation force sort of approaches. The scaling dimensions from applications, consumers, and B2B, it will be either inference throughput, which is like concurrent request, which you can scale your solutions horizontally. Say we are Kubernetes native, you can scale your pods up and down every day. If it's based on complex workloads and complexity of the workload, it will be vertical scaling. Hey, I have to beef up my CPU and number of GPUs. That requires vertical scaling. That's more problematic. And then obviously context length, number of tokens you're processing and passing into model, it grows every day because you want to pass more data, more data, more data for better data insights generation. So your context is growing. Growing context requires bigger memory. That's why all this RDMA technology is coming into the picture with the ION. So deployment strategy, on-premise cloud hybrid, obviously the Europe is on the favor of on-prem nowadays, which we love as part of Red Hat. So, but it will be kind of a between on-prem and cloud, which is pointing to hybrid cloud strategies to able to handle the burst traffic. So there is a reality of there's a static traffic every day you're facing, and there's a burst traffic which you may not have capacity for, where you can leverage hyperscalers with the same consistency across the platform. All right. So I saw one slide today, which again, I'm not necessarily a big fan of and I agree on it, which was like, oh, we have this new design. What about security? Oh, we add a firewall to it. Firewall, adding a firewall to your blueprint doesn't solve your security problems. You're just circumventing for day one. Day two, you have bigger problems. So the security has to be in mind from architectural perspective as well as workload requirements perspective. How can you do it with AI? It has to start with data governance. The whole holistic way of doing secure things, safe things with data, you have to start with the data governance. So you got to start from the acquisition channels, ingestion layers, processing layer, storage layer, and then you pass into access layer. Say who's going to able to access this data? What attribute-based controls should I have on it? Shall I have a context-based access controls? Intent-based access controls, and then you're going to audit and compliance layer, which obviously everybody needs. You have to prove that you're doing things right in a way that you can prove to your regulatory offices. All right, so too much talking. The reality is what you believe, what you experience. So we have a repo, Telco AI experiments. We have revenue assurance demos and this and that, not necessarily demos. We also clean up the data for you under data folder. So data is there under data folder, as well as we put those data sets onto Hugging Face as well. You may feel free to go just skip the Jupyter Notebook part of the things, just consume the data and use that data for your new experiments, okay? Again, better the data, better you can produce insights and machine learning, applied machine learning AI approaches. So enterprise observability experiments where we are trying to promote open telemetry use within the code, such as Java, Python, and C++. And we have a new project coming with eBPF, black box harvesting as well, to enable better data available to be consumed by applied AI. All right, here we go. Too much talk. Thank you for your time.
Yeah, thanks, Fatih. So just to wrap it up, I know if your head was spinning before, it's probably spinning faster right now after the presentation. So don't worry. By the way, you can download the presentation from the schedule website. But if you're interested in the topic, I want to remind you again something we announced this morning, and we'll talk. There will be a presentation in more detail soon. We are launching a new open source project under Linux Foundation Networking that will hopefully help everyone accelerate their path towards developing AI applications for networking. So these new projects will be the home for anything related to developing AI applications for networking. It is based mostly on seed code that was generously donated and contributed by Infosys, but we already have a broader community with community members working on thinking more broadly about what we need to include in this project. So we're folding in some of the previous activities that we have under the Linux Foundation networking, namely a piece of the Thoth project under Anuket that is dealing with the anonymization of telco-specific data, and also some of the work we initiated under an AI task force that we ran under LF Networking, which mostly concluded in the recommendation to have those data sets that Fatih mentioned in the beginning of his talk, which are the basis for everything. So it is already launched, and we welcome anyone. It's an open source project, and following the tradition of Linux Foundation, everybody is welcome to participate, and by participate I mean not only contributing code, but coming in, discussing use cases, discussing requirements, discussing ideas for technology. So please join us. Please start following this project with the mailing list and everything. So yeah, a lot of exciting things will probably come of this project, and everyone is welcome to take part. Thank you.